So chem, we're 3.3. So again, what should have happened, you should have read, studied, taken the 3.3 quiz, and now we're hitting up some answers. So here these come. If you have questionable answers, just put questions as you grade them, and we'll sort out those questions later on. 1 is molecule. 2 is chemical formula. Also acceptable is molecular formula. They're the same. One's not better than the other. You just pick which one your favorite one is. 3 is either the law of definite proportions or it's the law of constant composition. Pick whichever one is your favorite. There's not really one that's better than another. Just pick one. Those are the 3 new ones. Molecule, chemical formula, or molecular formula. Law of definite proportions or law of constant composition. Starting on 4, it's the stuff we had from other days. So 4 is physical states. If you just had states, I'll take it for a day, but that should really be physical states. 5 is the same throughout. 6 is not the same throughout. 7 is a mixture, just one word mixture. If you have other words in there, that'll make that one wrong. 8, we have homogeneous mixture. You need both words to get that one right. Solution, and then pure substances are the categories. Explanation of pure substance is that there's no variation of proportion. An example of that would be water or sugar, H2O, CO2, acids, I said, a few other options. Solution and homogeneous mixture start off the same. They're both composed of 2 or more pure substances. But for homogeneous mixture, the proportions can be varied without limit. For solutions, the proportions are varied within certain limits. So again, they start off composed of 2 or more pure substances. If you missed that part, that would be a half off at least. And then for homogeneous, proportion is varied without limit. Solution is proportions are varied within limits. If you forgot the word proportions, that would be like a half pointy kind of thing again. If you didn't have the without limit or the within limits, that just makes that wrong, because that's the key item there is homogeneous is without limit, solution is within certain limits. If you didn't mention limits at all, I don't care what else you had, that's just off. Solution, you could basically have put anything drinkable. Could have put grass as well if you wanted to. Unpolluted air is the only thing you can say for homogeneous mixture. So like the air we breathe, that's about it. 17, you should say it's a pure substance. If you didn't say it's a pure substance, you're out a half. It can be broken down into 2 or more simpler substances. If you didn't have the or more, I'll live without that. But we should include the or more because not everything gets broken down into 2 things. Sometimes things get broken down into 3, 4, 5, however many they may be. So pure substance can be broken down into 2 or more simpler substances. 18, you could just say that it can't. So even if you mussed up 17 somewhat, 18 said you can't do that. I'll give you the full point on 18 for just knowing it's the opposite of 17 and saying you can't do it. 19 is the smallest piece of an element that can exist and still show the properties of that element. The showing the properties of that element is crucial. You can't score without showing the properties of that element. I'll go half. Smallest piece of an element that can exist, I'll go half. Still show the properties of that element, I'll go the other half. But that is the scoring of that stuff. Homework off of this, 1K and M is doable now. Number 6, they're going to want you to do something that we'll practice in a second, as well as we'll do some stuff to get ready for 7. So here's some notes I have. For 1, I made a note, molecules are made out of atoms. Okay, the atoms are the smallest piece of an element that can exist. Then compounds are made out of multiple types of atoms. So there are hydrogen atoms, there are oxygen atoms. If they make friends with each other and you have H2O, you now have a molecule of water. Okay, hydrogen is just hydrogen, oxygen is just oxygen. But when you put them together, you have water, H2O. In the homework, what they'll ask you to do is to say, like, if we have one molecule of this thing, tell how many atoms you have. So for something like this, you'd want to say that hydrogen, you have 2, and oxygen, you have 1. If I say something like CO, carbon monoxide, they expect you to say C stands for carbon, there's 1. O stands for oxygen, also 1. Anytime we lack the subscript, we assume it's a 1. If they say something like H2SO4, which is sulfuric acid, they want you to say hydrogen, there's 2, sulfur, there's 1, oxygen, there's 4. That's what they're looking for from you. Homework question 6 is doing that. Homework question 7, they just go in reverse and they want you to write the formula. So if they said the hydrogen 2, oxygen 1, they just want you to put H2O. Okay. I would just write them in the order that they named the elements as well. So, I mean, if they said that sulfur had 1 and they said that first, you'd probably end up just writing that first for now because you don't really know why to put anything in any certain order. So if you go in the order they give you the elements and the counts become the subscripts, you should be good on 7. Other notes that I have off on the side of like number 3-ish is that elements lose their own character when they form compounds, but not when they form mixtures. And by mixtures, I mean like heterogeneous kind of stuff. So if your chair is made out of steel for the legs, and you make a mixture to have your chair where the seat is plastic and the chair is whatever metal I just said on the legs, in a mixture like that, the metal still retains all of its characteristics as a metal. But if you have compounds formed to do these molecules, hydrogen acts a certain way, oxygen acts a certain way. But when you put hydrogen and oxygen together to make water, water no longer acts that way. For example, hydrogen is tremendously explosive and flammable. Okay? If you have hydrogen near a flame, you have death. Okay? Water is obviously not flammable. Water puts out fires, right? So hydrogen will act like hydrogen when it's alone, but when you make these compounds, hydrogen gives up all of its individual characteristics when we form a compound and we form water. The other thing I have as a note on here is that compounds can't be broken down without changing the identity of the material. But mixtures can be simply separated. If we have our plastic and metal chair, that's a mixture, heterogeneous. If I want the plastic, I just pull it off. If I want the metal, I just pull it off. Okay? Here I have H2O. If I want hydrogen out of this, I can't do that without changing the water into separately hydrogen and oxygen, and it gives up all the characteristics of water. So again, when elements are going to lose their character when they form compounds. Elements don't lose their character when you form these mixtures. Compounds, you can't break them down without changing their identities back again, but mixtures you can. You can just separate your stuff. So that's the notes for 3.3, that's the homework advice from 3.3, and then all we need now is a 3.4 preview, and we'll call it quits. 3.4 preview is to read and come up with 4 new points. It's gonna, I think, be 4 pretty easy points to spot. I don't think there's gonna be a great deal of mystery in 3.4 as to what the words will be. They'll stand out pretty dramatically, I think, in the margins and in bolds and such. Then today's quiz from 4 down, nothing is going to change from 4 down. So keep everything from the physical states question all the way through to the what is an atom question. And then the top of today's changes to, instead of number 1, what is a molecule? So the molecule definition is kind of like the atom question, but it's different ending. So they both start off talking about being the smallest. So the atom was the smallest piece of an element that showed the properties of that element. What a molecule is, it's the smallest particle that can exist and undergo chemical changes. The smallest particle that can exist and undergo chemical changes. 2 stays the same. I went with molecular formula on mine. If you want to go with that for mine, feel free, but if you really want to insist on chemical formula, that's right too. But the answer I've kept day by day was the molecular formula. Number 3 stays the same. I went with law of definite proportions. If you preferred the other one, you can do it, it's right. I just prefer the law of definite proportions on mine. And then there's one follow-up question that I just got done saying, what happens to elements when they form compounds, but not when they form mixtures? It's that they lose their own character. So what happens to elements when they form compounds, but not when they form mixtures, is they lose their own character. Like my hydrogen has lost its explosiveness when it made H2O. It lost its character. But if we were doing mixtures, it doesn't happen in the same way. That's it.